Alright, and welcome back. In this video, we are going to be going through Chapter 9, Section 5, titled Inscribed Angles. By the end of this video, we should be able to solve problems involving inscribed angles and angles formed by chords and tangents. So please have out your guided notes, and let's begin. So just to make sure we're all on the same page of what an inscribed angle is. An angle whose vertex is on a circle and whose sides contain chords of a circle is an inscribed angle. So if we look at our diagram over on the right-hand side, if we're talking about angle BAC, we're going to notice that A is the vertex and it lies on our circle. AB is a chord and AC is a chord since points B and C also lie on the circle. So the inscribed angle BAC intersects arc BC. Likewise, inscribed angle BAD intercepts major arc BCD. And with this, the measure of an inscribed angle is equal to half the measure of its intercepted arc. So if angle XYZ is inscribed in circle A, then the measure of angle XYZ is equal to half the measure of arc XZ. Likewise, we can double our angle to equal the measure of our arc, and that comes into play for example number 1. So we have to find the values of x, y, and z. We know a circle has a degree measure of 360. We have one arc's value is 90 degrees, another arc's value is 80 degrees, we have z degrees, and then we have y degrees. We have an inscribed angle with a value of x degrees and another inscribed angle with a value of 55 degrees. So x is going to be equal to half of our arc's measure. Our arc's measure is 80 degrees, therefore half of our arc's measure is going to be 40. For y, we know that half of our arc is equal to our inscribed angle. So we multiply both sides by 2, and we double 55, and we get 110. Now, to find z, we're going to take 360, which is our total degree measure of a circle, and subtract everything else, all those other measures of each arc. So 360 minus the sum of 80 plus 90 plus 110 is going to give us 80 degrees. So z is 80 degrees. With this in mind, please work on problems 1 through 5 on the guided notes and resume when you're ready to move forward. Alright, if two inscribed angles intercept the exact same arc, then the angles are going to be congruent. An angle inscribed in a semicircle is going to be a right angle, which should make sense because an inscribed angle is half of our arc. Well, if we have an arc is 180 degrees for a semicircle, half of that is going to be 90. And likewise, if a quadrilateral is inscribed in a circle, then its opposite angles are going to be supplementary, which leads us to example number 2. So we're asked if the measure of arc AB is equal to 120, then what's the measure of angle 1? What's the measure of angle 2? Well, both angle 1 and angle 2 have endpoints that are arc AB, or that construct arc AB. So since angle 1 and angle 2 both intercept that same arc of AB, and we know AB is 120, it's going to be half of our arc. So 120 divided by 2 is going to give us 60. So the measure of angle 1 is equal to the measure of angle 2. They both have a value of 60 degrees. In example number 3, we are given if CE is a diameter, then the arc CDE is of what, and the measure of angle 3 is equal to what? So our solution, arc CDE is going to have to be a semicircle since we have a diameter, and diameter cuts our circle into two equal pieces. It cuts it into half. So major arc CDE is going to be a semicircle, which means that we have the measure of angle 3 is going to be half of that arc's value. That arc's value is 180 degrees. Half of that is going to give us 90. And likewise, in example number 4, I gave away the next part. Example number 4, we're given if the measure of angle 4 is equal to 75 degrees, the measure of angle 5 is equal to what? Well, angle 4 and angle 5, those are opposite angles of an inscribed quadrilateral, and those are going to be supplementary, which means that the measure of angle 5 is going to be equal to 180 take away 75, since we know the measure of angle 4 is 75. So we get 105 is the measure of angle 5. With this in mind, please work on problems 6 through 9 on the guided notes and resume when you're ready for one more theorem and example. So the measure of an angle formed by a chord and a tangent line is equal to half the measure of that intercepted arc. And that may sound a little bit confusing, but once we start to apply it in example number 5, it should help clear up any confusion. So if ray xp is tangent to circle A, so ray xp is going to be tangent to our circle A, and the measure of arc xzy is 260. So xzy is 260. We are trying to find the measure of our arc xy and the measure of angle pxy. Well, we know that an entire circle has a degree measure of 360. We know 260 of it is already taken up with arc xzy, which then means that arc xy is going to have a measure of 100 degrees. 360 minus 260 then gives us 100. Now we have to incorporate this new theorem about the measure of an angle formed by a chord and a tangent is equal to half the measure of the intercepted arc. We now know that our arc is measured in 100 degrees. Arc xy is 100 degrees, so we cut that in half, and that's going to give us 50 degrees. So the angle formed at the intersection of a chord and a line tangent to the circle is always half of our arc. Likewise, if you think the opposite way, our arc is double that angle. If you're given the angle, you double it to find the arc. With this in mind, please work on problems 10 through 21 on the guided notes. Keep up the great work. Keep making yourself proud. Let us know if you have any questions, and we'll talk to you soon.